Okay, so it's changing heat energy number 3, homework help video. First of all, you always want to start these labeling the melting point for water is 0 degrees and boiling point, which is 100 degrees Celsius. If it's for a different compound, copper or neon, look on the previous page and it gives you its melting and boiling points. So we're going to go through until we hit the melting point, in which a phase change into a liquid takes place. Then we're going to move up to hit the boiling point, in which our second phase change takes place, going into a gas. And then let's go ahead and label where we're starting and where we're ending. Okay, so we're starting at 0 degrees Celsius in the liquid phase. So this side would be solid, this side would be 0 degrees liquid. So we're starting here, okay, because it says the liquid, not a solid. And we're ending here at 70 degrees Celsius. Okay. So shade in everything in between. All right, so we only have one step problem. Okay, this entire phase right here, this entire incline there, is we're going to use CP of a liquid. So your formula is going to be Q equals CP times grams times delta T. All right, CP of liquid water, again, the previous page, you can look up the CP of liquid water. You probably remember it is 1 calorie per gram degrees Celsius. Those units will cancel out. We have 72 grams of water, and our change in temperature is from 70 degrees to 0 degrees. Okay, so final minus initial. We're warming. So our change in temperature is just simply 70 degrees Celsius, and that will give you your 5,040 calories or 5 kcals. Okay, all right, next part. Let's go ahead and I'll help you out with number 2 a little bit. All right, number 2, here's what we're going to be doing for that one. Okay, number 2 says we're starting at 25 grams of copper. We're starting at 1200, and we're going to go ahead and end at 1083. Okay, so let's go ahead and label our melting points. Again, look on the previous chart. The melting point of copper is 1083, and the boiling point of copper is 2582. Okay, so let's draw our curve. Phase change. Always looks like that. Let's go ahead and label where we're starting and where we're ending. All right, it says we are starting at 1200 degrees Celsius, liquid. 1200 degrees Celsius is maybe somewhere in there. And then solid, 1083. So again, 1083 is the melting point. So are we here at a solid or here at a liquid? Well, the directions say we're at a solid. It's already gone through a phase change. So we have one step and then 2 steps. Okay, so it's a 2-step problem. All right, and we're cooling. All right, first step. Right here, our phase change, step number 1. Okay, step number 2, our temperature change. Step number 2 is our phase change. So step number 1, let's go ahead and use our Q formula. So we're going to be using CP of a liquid and for the first step, and then delta H of fusion for the second step. So Q equals CP times grams times delta T. Okay, and we need to look up our CP of a liquid for copper, and it is 0.087 calories per gram degrees Celsius and 25 grams. And then finally our change in temperature. Now we're going from 1200 to 1083. Okay, so 1200 to 1083. We're stopping right there. Okay, so that's our change in temperature. So the difference in that would be negative, since we're cooling 117 degrees Celsius, which gives us our final answer of 255 calories. And I'm going to go ahead and put it in kcals because we'll eventually need to do that anyways. I just moved my decimal 3 times to the left. All right, that's the first step. Second step, phase change. And we're going from a liquid to a solid, we're cooling. So we're gonna use our delta H of fusion. So this one's gonna be 25 grams. We're basically just gonna set up some dimensional analysis. Molar mass of copper, look it up on your periodic table, is 63.55 grams in 1 mole. That's for copper. And then delta H of fusion for copper, you look it up on that table, is 3.11 kcals per mole. I'm going to go ahead and put a negative because that is losing energy, right? It's cooling. And this one should be a negative as well, because anytime we're cooling. They're all both going to be positive or both going to be negative. They're going to be negative if they're cooling, both positive if they're heating. That gives us 1.22 kcals. Add them together to give you your 1.5 kcals for your final answer. Okay, for finally problem number 3 and 4, I'm just going to give you a little bit of help on this. I'm not going to work through it with, do it for you. So we're going to label our melting and boiling points. So again, look on your previous chart, 1083 is our melting point, and 2582 is our boiling point. Draw our general heating cooling curve, and I'll at least help you out with where we're starting and where we're ending. So this particular one says we're going to go ahead and start at 1200 degrees Celsius. So 1200 degrees Celsius is right about there, same place as our other one. And then we're cooling to 1000 degrees. So 1000 degrees Celsius right in there. So really, 1 step, 2 step, 3 step. Okay, so step number 1, step number 2, step number 3. Okay, so we're going to be using the CP of a liquid for step number 1. So Q equals CP times grams times delta T. Now remember the change in temperature for step 1. It's not 1200 to 1000. Step number 1 is 1200 to 1083. Okay, so just be careful when you do that one. Step number 2, same thing. Delta H of fusion, grams to moles. And then finally use your delta H of fusion. Multiply it in order to get your final value. And then finally, you're going to use your Q formula again for step number 3. Step number 3 again is going from 1083, okay, to 1000. 1083 to 1000. So the difference in change in temperature is 83. Okay, so finally last step. So the prior one's going to be a 3-step problem. And then this final one, we got neon, so we haven't used neon before. We need to look up its melting and boiling points. It's really, melting point is really cold, negative 248. And then negative 245 is where it boils. So there's only 3-degree temperature difference. All right, so we'll go ahead and draw our curve. Here we go. Again, plateaus always are located at the melting and boiling points. So negative 255, okay, negative 255 is going to be somewhere down towards the bottom. And we'll go ahead and label that. Negative 255 is going to be somewhere down there. And then negative 100 degrees, this isn't to scale, it's going to be up here. So 0 degrees would be way up here. All right, so really it's a 5-step problem. Here's our first step. Okay, that's step number 1. We're going to be using CP of a solid, so Q equals CP grams delta T. Step number 2 is simply just a phase change. Okay, that's step number 2. We're going to use delta H of fusion. Step number 3 is going to be this, and we're going to use CP of a liquid for that one. So Q equals CP times grams times delta T. Now again, when you do these temperature changes, remember, for example, step number 3, you're going from here to here. Okay, so negative 248 to negative 245. So you have a 3-degree temperature change. And then step number 4 is a phase change. You're going to use delta H of vaporization. So grams to moles, and then multiply it by the delta H of vaporization for copper, which is really high. It's 72.8 kcals per mole. And then finally, step number 5. You're going from, again, you're going from negative 245 to negative 100. Okay, so your difference is going to be 145 degrees. And you're going to go 145 degrees times the CP of a gas for copper, for neon. And then, oops, I misstated, yeah. Delta H of VAP, step number 4 is 0.41 for neon. I was looking at copper. So anyway, step number 5, CP of a gas for neon, which is 0.25 times 145 degree Celsius temperature change, because it's between here and here, and then finally multiply by the 80 grams. Okay. Make sure they're all converted to kcals, so that 5-step problem, add them all together, and you should get a large number, something, not going to give you the exact answer, but something a little over 5. You should have a little over 5 kcals, so that'll kind of give you a rough idea. All right, hopefully that helps.